For the students of the Bioengineering Measurements course Fall 2017 at McGill, I'm going to be solving the first problem from the practice problem set 4 that I posted on the My Courses last week. The problem says that a certain equipment produces electrical resistors with a mean value of 40 ohms and a standard deviation of 2 ohms. We were asked to find the probability of finding a resistor with a resistance value greater than 43 ohms, right? This is a simple normal distribution problem where your mean is 40, your standard deviation is 2, and you're asked to find what the probability of random variable x here is greater than 43, right? So if you were to plot the normal curve for this one, it's going to be a symmetric curve centered about your mean value 40. And what you need to do is to find the area under the curve for x values greater than 43, right? But to make your calculations and life a little bit simpler, what you can do is you can shift this graph slightly such that the mean is going to be 0, or your graph is going to be centered about a mean value of 0. To do that, what you do is you find your transformation variable z, which is given as x minus nu by sigma, right? So if you were to plug in these values, you have a z value of 1.5. If you were to plot the normal curve now, it's going to be centered about 0, and you now want to find out what the probability of z greater than 1.5 is. So your probability of x greater than 4.43 becomes probability of z greater than 1.5, which is the area of the shaded region here in this graph, right? So if you were to look up any normal distribution table, it can either give you this value directly, or sometimes what happens is your normal distribution table is going to give you a value up to a certain value here. So for example, it could give you the value of the curve or the area under the curve till z equals 1.5, right? So to find out this, what you can do is you can go about this in two ways. One is you can find out what the area under the curve is for minus 1.5, z equals minus 1.5, because since this graph is symmetric, this area is going to be the same as this area. Or what you can do is you can find out the area under the curve till z equals 1.5, which is the area under the curve here, and 1 minus of this value is going to be the area under the curve for z greater than 1.5, right? So either way, if you were to look up your probability of z greater than 1.5 is given as 1 minus 0.9332. This is the value if you look up any of the tables, which is 0.0668. This is going to be the area under the curve in this region here. Either way, the answer to the question is the probability of finding a resistor with a resistance value greater than 43 ohms is 6.68%. Hope this helps.